ground basics, and you'd be surprised how many times I'm in meetings with the AT&Ts, the Verizon, CenturyLinks of the world, and just spending a 20, 30-minute primer, which I'm about to give you right here, is an extremely helpful level set. And by the way, these slides are all out there. Feel free to use them if they are any use to you. So, oh yeah, recent sightings. If you were at Cisco Live, I was out there. Maybe we bumped into each other in the hall. And I've given similar presentations at US Telecom and the IP possibilities. You might have to stand close to the laptop. All right, so we're going to talk about something, a couple mandatory, you have to do some marketing slides. What is the industry doing? The internet is growing up and to the right. We have to have those obligatory slides. But then we're going to get into something called the SE-MANO model. So this is the closest thing we have to a standard way of virtualizing network functions and rolling them out to end customers. We're going to introduce some definitions. If you put the word open in front of any networking term you've ever heard of, there's probably a term or concept out there that will match that. Okay? We'll get into the bare bones basics of cloud. Everybody should hopefully have a better understanding, if you don't already, of cloud by the time we walk out. If we have time, you'll play it by ear. Somebody keep me honest on time. I don't want to, bore anybody. But if we have time, we can get into some netconf yang basics, talk about a product or an acquisition we made, which I believe will be the best acquisition Cisco ever made, called TailF. And then finally, we'll close out with some things on how does the virtualization world affect our day-to-day jobs as network engineers and architects, things like that. And then maybe hit universal CPE / vBranch. So keep it interactive, throw things, ask questions, whatever you guys want to do. Hopefully have a little bit of fun. So, lots of changes. I believe what we're doing right now, what we're going through, is probably the biggest change this industry has ever seen. There are new technologies coming at us, foundational technologies that, if you're like me, I got into networking so I never have to write another line of code. Okay? Unless you're 2 years away from retirement, that's not a good philosophy to have. So we'll talk a little bit about that. We're seeing big changes in the service provider world. We're seeing something called software-defined WAN from the enterprise world. We'll talk about that quite a bit. And we're seeing business models completely change out there. Things that I started with 20 years ago when I tripped into this industry, completely different nowadays. What's driving these changes primarily is open source software. You can download it for free, use it as much as you want, use it anywhere that you want. You can contribute back to it if you want. The ability to orchestrate things remotely, programmability and automation, and then finally x86. We're seeing, I don't think we have one here, but your appliance-based routers. We've got an appliance that's a firewall, appliance that's a switch, and we're seeing a software version of that show up on a plain Jane generic server. So this is big, big impacts to how we do our jobs and continue running networks. We're seeing traffic patterns change. Used to you'd have a local data center on your site, but now how many companies are using Amazon Web Services? How many people are using Azure? There's a lot of our workloads that are taking place. When I go to Facebook, I'm using the cloud. You check your Gmail, you're using the cloud. So a lot of the traffic patterns are not staying here in the building anymore. They're going out to the cloud. And so the edge is moving further out as well of the local network. I love this concept. I'm not always a huge fan of Gartner, but there's the Gartner Hype cycle. So how many times have we read something in the press, oh, it's going to change the world, people get really, really excited about it, and then it just kind of plummets. So it feels like, in general, we're about here when it comes to virtualization and software-defined network. Okay. So something to keep in mind as we move forward, and what you see in the press. As the cloud has evolved, the first move out there was in the enterprise, a little company called VMware, which you guys might have heard of. I could take 10 servers that were running 10%, put them on one physical server, and then save 9% of my cost, right? So they thought it was going to save us a lot of money, but because of the extra overhead of administrating it, it didn't work out so well. Okay? So the next iteration is they went to a public hybrid option. I'm going to run some things in the enterprise, some things out on the web. Amazon Web Services, that's where they really started coming around. So we didn't see the cost savings there that we thought we'd get, high availability. How do I do policy, like network security? Can I extend that seamlessly into my cloud-based offerings? So there are a lot of things that missed there. Then we kind of withdrew from there as well, tried to do some self-service things, the elasticity. You'll hear me use this word a lot. One of the nice things about the cloud is, if I have one router, let's say I'm monitoring the throughput of that virtual router, when it hits 80%, I can spin up 3 more and load balance between them. So the analogy I use there a lot is tax season, right? When is the CPA going to be the busiest? Do they need to buy servers for how busy they're going to be in March or April, or can they just rent those servers for 2 months and not have to have those resources on their books? Can they expand out to the public cloud, use those resources for the time that they need them, and then pull back for their regular day-to-day? So finally, here we are at private cloud. We're taking things like Amazon Web Services. If you heard of something called OpenStack, it actually evolved out of too many federal projects, U.S. government projects, being in Amazon. But they'd already done all this development work against Amazon APIs, so OpenStack was born as a way to come and re-privatize a lot of the federal government projects that they were using the cloud as well. Because you can bring in servers, you got to rack stack them. By the time I want to spin up a couple web servers, that can be 3 to 4 months. Or I can put in my corporate card at Amazon, and they're up and running in 15 minutes. Right? So that's the appeal of the cloud. Software-defined network, or software-defined WAN, which is a form of software-defined networking. So a lot of enterprises, they'll use service providers like the AT&T, CenturyLinks, Verizons of the world, and they tend to pay fairly high-end dollars for MPLS circuits. Those things are guaranteed secure, they've got uptime, you've got great customer support, but the internet over the last couple of years has gotten a lot better. There was a time where the internet was flaky as anything, so you've got a lot of people here in the enterprise, CFOs saying, you know what, at home, if you've got Google Fiber just came into my neighborhood, they're going to offer me a gigabit for $75 a month. So $75 a month, even though that's the public internet, that's pretty appealing. What if I did a secure tunnel over my internet connection back to my headquarters, and I use that for my redundant link? And then I can set policy here at the branch that says Facebook's allowed to go that way, voice is allowed to go that way, but my intellectual property, the stuff that really makes my business flow, I'm only going to allow to go over this MPLS link. So now I'm in a position where the network is defining policy. Which applications are allowed to go south, which ones are allowed to go north. If there's a failure here, do not let them fail over south. So you have a lot of policies that we're now going to be playing with in the network. We're going to see the service provider community, perhaps getting more opportunity to offer services because of that. Because this branch, if I've got to run dual firewalls at every single location, that's a lot to manage. That's a lot of people I have to hire. So the service provider community is going to have a really good opportunity here to help manage these services on behalf of the SMB community and the enterprise. Does this make sense? All good? Cool. Awesome. So what does this look like moving forward? In the olden days, we'd have a switch, we'd have a firewall, we'd have a router, we have all these appliance-based solutions. Now we're just going to put in racks. I don't know if you guys can see this on the back row, but these are just racks of x86 compute. So what we're going to do is carve out virtually on any one of these servers. Again, we can grow and shrink these on demand, but we're going to carve out x86 generic compute to put these services. So I've got a lot more flexibility now to grow and shrink those services dynamically. Another example I use sometimes, we got the Olympics that's about to come up. So how many videos are we going to be watching on the Olympics over the next month versus 6 months from now? I really need those resources for the next 30 days. Not so much after that. So I can grow and shrink my resources on demand as I need. So this brings us to the ETSI-MANO model. So the European Telecom Standards Institute for doing network function virtualization. What do we need in this room if we're going to take our knowledge of the network and apply it to a virtual world? So there's a couple concepts here to be aware of. The NFV, Network Function Virtualization Infrastructure. This refers to things like VMware, things like OpenStack. What is the actual engine that runs my virtual instances? I'll show you an example here of what the NFVM does, the Network Function Virtualization Manager. So this, I'll just show you an example here in a second, and then the orchestrator is the policy. How do I want to build these virtual network functions? How do I want this thing to look? And then in general, in front of that, this would be raw REST calls coming to it, and then typically you have a portal on top of that. But that's the closest thing we really have to a model. To just give you an example, maybe this is VMware. I don't know if you can see this. I've got a physical server and then a hypervisor. So this could be VMware's ESX, could be KVM OpenStack, maybe Zen. But on top of these hypervisors, I can run virtual machines, virtual servers, virtual routers, things like that. So here we go. Things are normal. All of a sudden, the demand is spiking. I'll have to read these guys, the text for you guys in the back. So demand spikes. So the NFVM, the Network Function Virtualization Manager, then immediately spins up more apps. So I was load balancing between 3, demand spikes. Now I'm going to load balance between all 6. So now we're coming along. Everything's good. We're all hunky-dory, except then the server catches on fire. So the NFVM, the manager says, oh, no worries. I had 6. I need 6. I want 6. I've only got 4 now. So I'm going to spin up 2 more on the next server down the road. So these are the type of things that the NSB Manager does. The orchestrator says, I need the appropriate load at any given time, and the manager goes and carries out those and makes sure that whatever my intent is what's actually running out in the network. So, any questions there? That was kind of the intro to the what's going on.
Shoot me if I jump too far ahead. With the move from kind of the trend from moving from hypervisor-based virtualization to container-based, how does that impact the functions of what we're trying to virtualize in terms of putting everything in OpenStack?
Hold that thought. I've got a slide on containers. Cool. Perfect street name. If I don't answer it, ask it again.
I will.
For sure. Got another one?
Yeah.
Yep. Oh.
The locations of the physical servers, do they have to be in the same location, or can we spread them out throughout the country?
You can spread them out. You just have to take into consideration things like jitter.
Can you repeat the
Oh,
question?
repeat the question. Absolutely. So the question was, do the servers have to be in the same physical location, or can you spread them across the country, I believe you said? Yep, theoretically. So I would say we still have to take into consideration jitter, latency, the normal things we have to think about with the network. But yeah, you can go spread them any way you want. The other thing this does is that functions that have traditionally lived together on the same device, like IPsec and tunneling, do not necessarily have to live on the same device anymore. Maybe it makes more sense just to encrypt, but have a straight shot to a tunnel that lives somewhere in the cloud. So now we can start to disaggregate functions that have traditionally lived together. So a couple definitions. OpenStack is a very scalable public, well, it can be public, can be private, but it's open source software to run your cloud. VMware, if you guys are familiar with VMware, I have to get the ESX hypervisor. Then if I want to use vCenter, I have to pay licensing fees. This is not exactly an apples-to-apples comparison, but imagine that environment-ish, but I can download it for free off the internet and use it anywhere I want. So we're seeing a lot of interest in OpenStack rather than a VMware for business cases that are based on public services. We're seeing amazing growth. We just had the 13th, 14th OpenStack Summit in Austin a couple months back. Biggest, I think they almost doubled their attendance from the previous one. So there's amazing community support for this. There were various open source clouds over the last couple of years, but it very much appears that OpenStack is emerging as the open source cloud of choice that's out there. If you'd like, and I'm mindful on time, so maybe we can save the demos for the end. If you want, I can fire up, show you the GUI, show you with some of the capabilities. I've got a bunch of OpenStack servers running in my own lab with a lot of virtual routers, switches, firewalls, things like that. So I'm mindful of the time, so why don't we, if it's okay with you guys, maybe we can hold the demos for now. So OpenVSwitch. Imagine you take a Cisco 3750 or equivalent, and I write a virtual version in software. This is the typical Linux virtual switch, OVS for short, that you see in most Linux operating systems. It performs pretty well. We can get into some of the details if anybody really wants to show off at parties, but at the end of the day, OpenVSwitch is a Linux completely virtual switch that sits in software on the server. I've got virtual taps, think of those as device interfaces, and they connect in, and it still does Mac learning, it still does bridging, all the things we've grown up with over the last however long you've been in networking. OpenFlow is an interesting one. This is, it reminds me of that Gartner Hype cycle. OpenFlow is a way, instead of, say, turning on spanning tree in your layer 2 network, what if I have a controller that goes and says, allow these 3 ports to talk to each other? So I'm not doing it on a protocol basis. I'm doing it from a computer, a controller in the sky. Another analogy, let's say rather than turning on an OSPF or a RIP or a EIGRP, you send somebody to do static routes across your entire network. Okay? But that's got to be a really tough ask for one person to do, so I'm going to remotely program those static routes in every single router across my network. So that's the basic concept of OpenFlow. OpenDaylight is an open source controller for doing things like OpenFlow. So that's Cisco founded this, but it's an open source movement. You can download it for free again as long as your switches support OpenFlow. You can download it, use it, program it for free. There's a community that's always adding new features to it. Open Platform NFV. So this is an approach to allowing developers to more rapidly spin up an environment. So I can spin up OP NFV and start playing around with things like Cisco CSR1KV. That would be our virtual, think of an ASR 1000. The virtual version of that is the Cisco 1000 or the CSR1KV. Couple of potentially confusing terms if you're just getting started in this space. So what is software-defined networking? SDN, I try never to use that. That's like cloud was 3 years ago. Anything and everything is cloud. But software-defined networking tends to be the whole what's going on in the industry. Network function virtualization, NFV, is the concept. If I'm going to take virtual routers and firewalls and virtualize them, that's going to run in an NFV platform. And the specific device that you virtualize, that's the VNF, a virtual network function. So VNF will run on an NFV platform. I think they intentionally use these 3 letters way too much just to confuse them. All right, so if you really want to impress people at parties, these are the basic foundations of the cloud, right? So you've probably heard infrastructure as a service or something as a service, IaaS, PaaS, SaaS. What the heck is the difference between all 3 of these? The difference is, what do you run? What do you have control over? If you're going to go into your own data center and set up OpenStack or VMware, you're running a private cloud. You control the whole kit and caboodle, hardware all the way up to the applications. If I go up to Amazon, they have an infrastructure as a service. It's their primary offering. I don't care about the hardware. I don't care about the storage. I don't care about the hypervisor. Just give me a Red Hat operating system. And I will load whatever applications on there I want, whatever databases I want. If something needs to be patched, I patch it. Okay? That's IaaS, infrastructure as a service. Platform as a service, I don't even want to be bothered with the operating system. I don't care what OS you're running it on. I just want to go run Exchange. Give me Exchange. But if something needs to be patched in Microsoft Exchange, it's typically up to me. And then finally, software as a service, I don't even want to be bothered with that. When was the last time you checked the version of Gmail on your account? We don't care. Somebody else worry about it. Somebody else take care of the whole thing. Google runs the entire thing there for you. All right? So hopefully, I know when I first started on this, none of this made sense to me. So this is kind of the decoder ring to IaaS, PaaS, and SaaS. Okay? Any questions here? Cool. So a couple examples. Amazon Web Services, Rackspace, good IaaS examples. Google App Engine, Azure would be PaaS examples. Salesforce.com, Google Mail, SaaS examples. Okay. All right. So this is where we get into the basics, and you'd be really, or maybe you wouldn't be, but I use this all the time when we're doing executive briefings, when we're doing, meeting with the AT&Ts and the Verizons of the world. It's usually pretty helpful. So just to cover the basics where you can really understand what's under the covers, take your laptop. Okay, this is my laptop. You've got hardware, you've got an operating system, could be Windows, could be Mac OS, and then I run applications. I've got Outlook, Excel, Firefox, just got various applications running on that, right? So nothing out of the ordinary here, right? There is an application that you can download for your laptop called a Hypervisor. Okay, it could be Fusion. If there's any Mac users, there's Fusion, there's Parallels, and with this Hypervisor, I can provide the illusion of hardware to a guest operating system. So on my Mac, I can run Linux, I can run a Cisco router, and I can run Windows all next to each other because I have 16 gigs. It wouldn't be too much, but because of this thing called a hypervisor, in my case, VMware Fusion, I can provide the illusion of hardware to these guest operating systems. So there's an entirely new operating system running in this window, if you will, and then applications on top of that. So I've got a nested operating system because of this application called a hypervisor. Okay? So this is what makes cloud possible, is a hypervisor. You guys hear me in the back, by the way? Okay, cool. So there are various hypervisor options that are out there. VMware really took over the market when they came out. Microsoft has made great inroads in Hyper-V, coming back and taking back some market share. KVM would be the open source version. Download it as many times as you want, run it as many times as you want, absolutely free, community open source. Right? So this is the entire industry, this is the entire world. If we look at the space that I play in, and most of the network function virtualization space, it's really going to be in here, much more in the KVM space. The networking virtualization is definitely migrating toward a KVM, but it can absolutely work here in VMware and Microsoft. All right. So KVM, as I said, is an absolutely free, download it, put it anywhere, everywhere you want. It's open source software. We're seeing the majority of network vendors out there move to it. You know, example, again, our CSR1KV, our ASAV. KVM is the hypervisor that OpenStack uses. Okay? So we'll get to more on that here in just a second, but keep this in mind. When people say OpenStack, the hypervisor under the covers is KVM. So the basics is, you know, here's an open source KVM, VMware. So I've got hardware. I've got the ESXi hypervisor, I've got KVM. We've got a nested, we've got a converged hypervisor over here because there is no separate operating system. If I'm going to run KVM, typically you need a Linux. Could be CentOS, could be Ubuntu, could be RHEL, whatever you want to use. And then I run that as an application just like I did on my Mac. And then on top of that, I start spinning up virtual machines. Right? I'm providing the illusion of hardware to these VMs. They all have their own operating system, their own applications, right? So the problem gets to, and the reason why is because of, I've heard in the old days of the service provider world that we called it the stat-mux game, statistical multiplexing. But all that really means, it's a fancy way of saying, I've got 5 servers here running at 10%. I use a hypervisor. I put them on one physical server. Now I'm running the server at 50%. Much more efficient use of my resources. So where these things start getting complicated is when I move beyond 1 or 2 servers. It's one thing for me to go to 2 ESX servers and spin up some VMs. What about when I get to 50 servers? What about when I get to 500 servers? Now I need some way to manage that, so we take a controller approach. So I go into the access points in this building, right? We put in Linksys, well, not we Linksys anymore, but if we go switch by switch, it would take one person forever. There's no way to keep up with that. So we have a controller-based approach, where we have a centralized policy engine to control effectively and scale across multiple servers with hypervisors, right? So this is all OpenStack really is. If you have any experience with VMware, you've got ESX, and to really make use of it, you have to have vCenter. That's what OpenStack is doing with KVM. Right? With OpenStack, it is possible, but possible is not always a good idea, it is possible to mix and match your hypervisors. So OpenStack could be doing its thing with KVM per normal, but you can also go through vSphere and leverage an ESX environment if you want. You can go use the same thing with Microsoft. Why does anybody care about doing this? There may be an application, there may be a network VNF, virtual network function, that is only certified for one hypervisor. There's a lot of this going on in the industry because ESX has been around forever. OpenStack's now taking over the world, or slowly taking over the world. So how much development expertise do I put into maintaining versus moving? You know, it's a balancing act. So it is possible to mix and match your hypervisors. So in the olden days, life was good. Dogs and cats lived together in harmony. So we had laptops going through routers, hitting physical web servers that went through another router and hit database servers. We could troubleshoot that. Life was good. No worries. So now we get into the hypervisor world. First thing that got virtualized was servers and applications. We still went through a physical network. Then we went through hypervisors to get to your web servers, potentially, physical network, and then the database was on the back end. And, of course, we had extra capacity per the flexibility and the elasticity of the cloud. So now, where we're at, is we're virtualizing the network as well. So now we've got a lot of challenges on how to troubleshoot this. How do we troubleshoot where the MAC address is on this server? You know, there are ways to do it, but it gets more challenging. I might bounce through this hypervisor, hit a virtual router, not even hit the network again before I hit the web server. I'm back on the physical network and just bouncing around. So there will be times I bounce through a network function and an application without actually hitting the physical network. So we in this room sometimes can make our life a little bit more challenging. Okay. Underlays and overlays. Here's another term that's starting to pop up more and more. We have the physical underlay, things we've all grown up with. We've got physical switches, routers. We've got the virtual underlay. Could be an Ethernet over MPLS, could be MPLS, could be Q&Q. And now we've got the virtual overlay, which could be an IPsec, could be something along those lines. Maybe NSH, network service headers will take off. But we've got physical underlay, virtual overlay, 3 different types of solutions. And these become very important when we look at things like software-defined WAN. Cool. All right, so why in the world would I trade in my router that's got custom-built ASICs? I can do 10 gigs a second throughput at 64-byte packets, not even blink, not even do a sweat. Why in the world would I take that, virtualize it, and put it on some generic hypervisor? Right. The answer is not performance. That's often a concept that we in the networking space, we're always looking at throughput, packets per second, blah, blah, blah. The cloud is about elasticity. It's about flexibility. It's about the ability to say, you know what, on a Sunday afternoon, I might need one of these. But on a Friday night, I might need these and more. It's about being able to spin up and down dynamically the services you need when you need them. Okay? So that's often something that we in the networking space have to get our heads around. Yep. A concept that's worth knowing in this space is about fault tolerance. If you've ever played with VMware, I can actually have a server catch on fire and not even drop a ping that's going to that machine through something they have called a vMotion. But the requirement for that is shared storage. As long as I have shared storage, I can move workloads dynamically from one compute node to another and not even drop a single packet. So in OpenStack, that's called live migration, same thing in Microsoft. So all the cloud providers have them. The reason I mention this is just FYI, because we in the network have grown up with things like HSRP. We've grown up with VRRP. So the application guys, they needed this because they don't keep state and allow failure from one zone to another. So it's just something to be aware of. Now containers. The good-looking guy in the front asked about containers earlier. So containers, remember how in the hypervisor we had a guest operating system? We have the illusion hardware, then a new nested operating system, and then the applications. We're skipping the nested operating system in this case. Now, why containers? The real appeal of containers is that as long as I can isolate my applications from one another, I can come with IP version 18 tomorrow, compile it, throw it on here, and I'm done. I can separate that, and I don't have to do the regression testing to see if that broke my BGP or my OSPF. So the real appeal of containers, well, there's 2 real appeals in containers. One is, can I skip my dev test processing or testing and get things out to market much, much, much quicker? The other one is, it's a much, much smaller footprint. So we're being asked by various customers for things like micro routers, things that, very, very small routers. How many features exist in Cisco iOS? But how many features of those 19 million do we actually use on a day-to-day basis? So the appeal of a micro router that has a much smaller footprint, I don't have to worry about as many, the hypervisor layer at all, could be pretty appealing. They cover it? Cool. All right. So what does this impact? How does this impact our day-to-day in this room as we do our jobs, right? This is something I get asked quite a bit. So I always like to start with what is the difference between a network person and a software person. You'll notice I'm wearing a t-shirt up here. Half the time I do this in ripped jeans and flip-flops, right? Because that's much more the way the application guys think. They go do their code. They have a much more simple approach, by the way. They make a request to an API, and the API reports back. We in this room, we get into big committees, and we argue out what a protocol could be. We're should be, and does your box do the same thing as my box, such that OSPF works across the entire, it's a distributed state network, right? Protocols. Application guys, they don't think like that. They just say, hey, give me what I'm asking for, and you report back. So it's a much more simple approach, if you will. So with that in mind, we have to start thinking about how does our life change. I tend to work in the service provider community a lot more, but what happens to our redundant power supplies? If it's a virtual piece of software, when was the last time Microsoft Word had redundant power supplies, right? No such thing. Redundant processors, redundant backplanes, does it have NEBS compliance? Do you have CALIA codes? All this good stuff tends to go out the window now that we're virtualizing things. So it's something to think of. Another one is, how do I distribute this across multiple servers? If I have this path, if I got all 4 of these functions, and they're on 3 different servers, do I really want the path through the network to look like this? Not very efficient. So the first thing we need to, well, we also, by the way, and I mentioned this earlier, we grew up with HSRP, but HSRP is not going to do you a lot of good in this scenario when it's on the same box, right? So there's some new concepts we have to come up with to make sure that our desired network design is actually what's going on. So we have the concept of affinity. Affinity is when I want all my things on the same server. Affinity is when I want the fastest throughput typically. I don't want to go bounce through this box 18 times, when I've got performance on my mind. Okay. You've also got anti-affinity. HSRP is not going to do me any good if they're both all in the same box. So anti-affinity says spin up your 2 functions, but be sure they're not on the same server. And there are ways to request this when you're talking to OpenStack and various hypervisors. So network service chaining, there's some yet to be fully baked standards that are coming out. There's one approach called network service headers, where I send the packet through and I don't actually do tunneling, but the header says be processed here, not here, here, and here. So there's some different approaches. The other way to do that is I do like a VXLAN overlay and actually manually plumb up each connection. If I want to bypass something, then that tunnel needs to go around. So we'll see which one of these approaches wins out in the standards bodies. Okay. So a couple slides on ISRV. This is a little bit of a sneak peek. So I debated pulling this out, but what the heck? It's already up there, and you've heard about it at this point. You've probably heard of the Cisco Integrated Services Router, ISR. So in the ISR, I've got the option to put a virtual server in that as a module. So what if we take that model and we flip it on its head? What if instead of doing that, I take a server and I put a virtual router on top of that? So some interesting possibilities start coming out at this point. Rather than deploying a virtual router, a physical router and a physical firewall and intrusion detection, what if I can spin up those things dynamically on the server, get the same function, but I've got one box to support, it's a smaller footprint, I've got the ability to do interesting things like use HSRP between 2 routers, do an upgrade of code, switch to a flash cut. There's a lot of interesting use cases that come from this, which I think I skipped. If you want, you guys will have the slides. You can go back and look at them. But the ISRV is a pretty interesting little box that's going to be coming out shortly. 8 ports of PoE LAN. Got some WAN ports. The HWIC slot, still call it HWIC. The NIM slot is really, really interesting. If you wanted to have a T1, if you wanted to have an LTE, something along those lines, you got your hard drive, and it's all in the same form factor as an ISR box. There's a lot of places you don't want to go put in a big honking server, right? So this is the exact same form factor as an ISR, and you've got various sizes to put, however many workloads is appropriate. You wouldn't use this thing to spin up, 100,000 loads or anything, but we're thinking somewhere between, 5 and 10 virtual network functions. Okay. ENCX demo, I can demo that here in a second. I actually think we're doing pretty well on time, but I'll show you the GUI to that. It's pretty cool. AT&T is doing a lot of work. It's showing up more and more. All right, another question I'm asked a lot. Are there really any standards out there for doing any of this VNF, NSB stuff? And so things are starting to emerge. So I thought I'd do a couple slides on NetConf Yang and something called TailF. So the enemy of the cloud is the swivel chair. If I have to go run to a box and then go physically run to another box, that's not where we're going with this industry. And so we need things like network APIs. You know, how many of us have written expect scripts to automate part of your jobs, right? I know I ran an entire General Motors plant early in my career with expect, and I could automate all this stuff. But anytime a vendor went out and they changed one little line of their code, the whole thing broke, right? So it's not the most efficient way. So what we need is something called netconf, because now I can do versioning. If they go change their version of code to something else, I can go request the old version. You know, I can do things like models. I can do Yang models that say, don't just give me an interface up, but give me an interface that has these capabilities, and I can model what a service looks like. Okay. I can describe, here's a PE, provider edge ID. And so I can do netconf Yang models. Netconf is the protocol with which I communicate with the network devices. Yang is a modeling tool which allows me to describe what I want my services to look like. So you'll see netconf Yang come up a lot more as we move forward. Another example, the difference between network people and application people is network guys, and the guys and gals, we always go for standards. So XML is a standard, but in this case, I'm looking at purple, green, orange. I've got a whole lot of gobbledygook. There's a newer protocol called REST, which is not a standard yet, but it's so much more pleasing to the human beings that are coding it that it's becoming used a whole lot more out there. So that's another example of how we in this room will have to evolve a little bit as these programming concepts come toward us. So just a quick example, you've got some BGP communities, so I can go model that in Yang. Container for community sets, so feel free to reference this after the fact. So that's what the Yang model looks like. If I was going to do that in XML, again, it's not the most friendly, human-friendly syntax that's out there, but the JSON is pretty friendly. I've got these community members under community member. It makes sense. It's much more easy for us human beings to read. So I think we'll see RESTconf with the JSON format be far more popular. So TailF, just to give you a couple concepts of what I truly believe will be one of the best acquisitions Cisco ever made. The ability to abstract complexity, like say it's an all Cisco shop, which we love this in this room. Yes, question?
A quick question regarding JSON. Is it based on C# or ASP.NET?
It's independent. It's independent. It's a communication format. It's REST really at the end of the day. RESTful API.
So it's REST.
Yes, it's REST. Oh, the question was, what is JSON format based on? So TailF has the ability to abstract the complexity of the individual implementations. So let's say, and we love this at Cisco, let's say you're an all Cisco shop, right? But even then, you probably have iOS, iOS XR potentially, you got NXOS, potentially even Sun OS. We have about a dozen different operating systems based on various acquisitions we've made over the years. So how do I script against all of those? How do I make a model across my entire network when even with an all Cisco shop, you've got different operating systems out there? So what we can do is create these Yang models such that I do one model and it gets translated to whatever the operating system is that's out there. So we bought TailF. We've got, I think, might be just over 100 vendors we support right now, but I model it once, and then that model can go apply whatever I've modeled to Cisco, Juniper, F5, A10, whatever you're doing out there. So I do it once, and it's multi-vendor support immediately. I'll show you an example here, I think, on the next slide. It's got Advantageous Operations in your network support staff. This supports Juno's format and Cisco formats. You'll learn those. Now I can program ALU boxes, I can do F5 boxes, all from a Cisco syntax or a Juniper syntax, depending on which one you prefer. So it's got a lot of advantages, not only with efficiency in the network, but your operations approach as well. So in this example, I go through, I set up an access list, do all my rules, and what happens is it gets translated to whatever device I'm talking to in the appropriate language by using, when possible, netconf, or we have these things called network equipment descriptors. which in essence, instead of having this be netconf or a model and version, I can actually SSH to the box and do it in its native language. So it's a very, very powerful tool that I think you'll see more and more. Question in the back.
So is this only going to apply to Cisco devices, or are you going to support other vendors?
Question was, do we only support this on Cisco devices, or do we support other vendors? We absolutely support other vendors. Here on the slides, I think I've got several examples. Oh, so even on the slide, I've got Juniper. You know, I'll probably get flamed for putting a competitor up there, but yeah, we support just over 100 different vendors right now. And even
I heard you say multiple vendors. I just want to clarify.
Yeah, absolutely. Yeah, that's a great point to make. And even if you come up with that 106th vendor that we don't support, we can come up with a new that NED, that network equipment descriptor, where we can natively go to the box in its own language. It takes about 2 weeks to develop something like that. So onboarding another vendor that's not supported is pretty quick. Yes?
So how does this work with, say, EIGRP only works on Cisco, so I'm writing that out and it needs to go to a Juniper box. How does it know to translate that, or do I have to already know ahead of time to program that?
All right, so that question, do I need to read? How would this work with an EIGRP that's something that's vendor specific? So we can't bend the laws of time with this, right? So it has to be something that the box is supported. We can't go program a 10 gig interface on an old 100 meg switch, things like that. But we can do things that are common. BGPs should be common, OSPF, firewall rules, the concepts. As long as we can do that translation from one vendor to another, then that's what you got. That's what we can do. Question. Okay. Yeah, in this case, we design it once. So this is a Yang model, basic firewall. Got my rules, got my group, and I can push it down to whatever vendors you have in your network. And the other advantage of this is that, say you have a vendor that you don't like that much, it makes it that much easier to swap out for the vendor that you do like. I was just randomly pointing up there. That's all that was. All right, so this is usually where people jump out with their camera phones.
Hey, Chris, you have a question?
Was there a question?
He's trying to ask a question.
Yeah. Oh, somebody on the WebEx.
We do, but there's, sorry.
Can't do it.
Sorry. You could mime. If you could mime it, then we'll do it.
Write it on a piece of paper and stick it up on the screen.
Yeah, write it on a piece of paper and put it up.
Absolutely. So what skill sets do we in this room need to?
Sorry, I don't know what's going on.
Okay. So what skill sets do we in this room need to be thinking about as we evolve into this? It could be this doesn't happen for 7 years, could be 10, could be 2, right? But one of the things I always try to do is what skills do we want to be thinking about and starting to adapt as we move on. So we've talked about a lot of this stuff already tonight. So x86 server virtualization, we've probably talked about that at length. How do we virtualize Linux, various environments, cloud orchestration such as OpenStack. We talked about OVS, OpenVSwitch. We talked about network controllers like OpenDaylight. There's new protocols we need to be more familiar with. NetConf, Yang, RESTconf, REST APIs, OpenFlow, function chaining, network function chaining, could be network service headers, NSH takes off, overlays and underlays, so VXLAN, the 4096.1Q limitation. People are sometimes concerned about that, so we can go up to 16 million now with VXLAN. MPLS over GRE, UDP, LISP, L2TPv3, automation tools. If you guys really want, I've got a couple backup slides on Ansible, things like that, but how do we automate the network through existing server IP tools? Management orchestration, and then finally one slide. I want to talk about this real quick. I got into networking and fell in love because I hated compiling my frickin' code and debugging my frickin' code back when I was doing Fortran 77 a long time ago. So Python, I think, is a programming language built for network people. So when I go to a router and I do a no shut, something happens, right? You go to Python, you type in a line of code, something happens. So either it works or it doesn't. I keep typing it in until it works, and then I take that line and I copy it over to my program. There's no debugging because you never write bugs in the first place. it's a beautiful thing. I'm actually enjoying coding. I can't believe these words are coming out of my mouth, but I'm actually enjoying coding again, having sworn never to write another line of code in my life. Yes.
Back to skill set.
Yes.
Certifications. OpenStack offers like Red Hat certification.
Yep.
And Mirantis.
Yep.
Is there anybody else, and what's the preference?
Those are the big two. Preferences is hard. Oh, the question was OpenStack certification. So it's hard to comment on your preference, which one's better or which one's not. Mirantis tends to be the installer of choice with people not very familiar with OpenStack, because it's got a nice web GUI. I give you an ISO. You do some Pixie boots, and your servers come online. And I say, you be a controller, you be a compute node, you be a Ceph node, whatever. The RHEL tends to be a little bit more for the code savvy, the open source savvy. Linux ninjas is what the CEO of Mirantis calls them. Linux ninjas versus VMware sysadmins. So the RHEL certification tends to be for people a little more comfortable with Linux. These are very large generalizations. At the end of the day, though, it's how do we get this OpenStack, or how this open source cloud up and running quickly so I can start using it and not have to worry about installing it. That makes sense. Question?
Just a comment, OpenStack has their own certification.
Yep, they do now. The comment was the OpenStack now has their own certification. In fact, what they call it, purple squirrels. I think in Austin, if anybody was there was this big table saying purple squirrels apply here. So it was trying to connect people that knew OpenStack with employers that wanted expertise on OpenStack. So there's a lot of, there is opportunity.
Are you a purple squirrel, or are you purple squirrel certified?
I don't know. I'm not sure how to say that. I don't know if hopefully I'm not a purple squirrel.
I prefer the Oompa Loompa certification.
Oompa Loompa.
Network expert and a programming expert. You know,
that truly is a rare breed these days. You know, there's opportunity out there for people that understand this open source code space and the network. Because if you look at the traditional expertise on both sides, how much do we in this space know about open source? Traditionally, I'm not pointing at you guys specifically, but traditionally, network people focused on the network because I friggin' hated coding. You know, I don't even bother with that space. And they know they're just going to assume infinite bandwidth on their side. I'll do whatever I want. I'll do multicast over the internet. You know, dogs and cats living in harmony. Right? So the ability to understand both of those worlds should be a pretty decent boost to one's career. Yes.
I was wondering if you could speak about the saturation with where we're at with the industry at large, with enterprise versus service providers, and as far as the hardware itself that supports this technology.
Saturation, sorry?
Yeah, as far as the rollout of SDN in general, and where we're at with the real world implementation of this, I guess, as the current state of the market, if you will.
So the question was, where are we with regards to rolling this thing out versus vision, perhaps?
Yeah, yes.
I will go back to one of my favorite slides, the Gartner Hype cycle. So something's invented, people go nuts about it, everybody's writing press articles about it, and then it falls off, and then slowly people find real uses for it. So my 2 cents, and this is worth everything you're paying for it, my 2 cents is we're in here somewhere.
With the actual rollout.
With the actual rollout. We're starting to go like, oh, everybody's, it's going to take over the world, which it may, but now we're actually starting to see some implementations. I've been in this space for the last 3 years. We have talking to customers. We have this proof of concept. We have it running in the lab. We're thinking about doing this. We're starting to see some stuff roll out. If you look at the AT&T Cord stuff, if you look at, Verizon's got, I think, 3 OpenStack clouds that they talk about in the press. None of this is, proprietary. It's all out there in the press, so you can go Google it. Yes.
Comment.
Oh, sorry, did I get your question, by the way?
Thank you.
Okay, cool.
Comment along that line. The more you look into all of these open source projects and see the various things that come out, if you go back and you look at OpenStack, 4 releases ago, Kilo or 4, and the components that were there to do nifty things, it's a small subset of what's in OpenStack today. There's more plug-in things coming out to work in OpenStack. There's Trove, I forget what it was, the bare metal one, Ironic. I knew it started with an I. And more coming, and that's just in OpenStack. Any other open project, OpenO, OpenVSwitch, you look at that stuff, and the rate of innovation is astronomical. So the bottom line is, I think we just. Chris wants me to be quiet. Okay. I think I just got going. But anyway, so I think we should talk.
Yep, there's a lot of nuances. I should have put up the slide actually of how you troubleshoot the network in OpenStack. So we're all routers, switches, fairly familiar with that. The networking model within one server in OpenStack is between that virtual router and the physical network. There are 7 layers that networking could break. And it's very possible every one of us in this room could find ourselves in a place where we have to troubleshoot that. So it's something to keep in mind. It's a brave new world. So I think I was almost done. Back to where I was. Left. So we were here, right? So, you know, feel free to email. I guess we're going to give out the slides. If you're not, feel free to email me. Again, Python, we did an example. We had this thing called, it was called 1PK that we did about 2 years ago. So we had a C module, took about 200 lines of code to do a function. We had a Java module, took 75 lines of code. Python took 12, okay? I can write 12 lines of code, right? Anyway, check out Python. It will, the entirety of OpenStack is written in Python. So yeah, just to summarize, crazy change, crazy technology disruption, new revenue. We're asking for new WAN models from the enterprise branch. Guys, this is the craziest change coming right at us like a freight train. So trust me, and if you take away one thing from this, start looking at these new technologies, start growing beyond just being the network people. You know, maintain your network knowledge because that will always be valuable. But the way we implement that knowledge is going to change as we involve all these cloud technologies. Okay? Any questions? How are we doing on time, by the way?
Oh, you got God's.
Yeah.
Oh, God's time. Okay, I'll go do the demos. Any questions before I jump into some quick demos? Yes.
Yes, I was wondering if you could go back to the elasticity and performance page. I was wondering, could you elaborate more? Like, with the elasticity of SDN, do you sacrifice performance, or is it like a substitute?
So the question is, do we, around elasticity, when we move to this virtualization space, do we sacrifice performance for that flexibility? So with caveats, the answer is almost yes. By default, without any tweaks, if I take a Cisco CSR1KV router, a virtual router, ASR1K, just without any hardware, and I put that on OpenStack, I'm going to see about a gig worth of throughput without any tweaks, just generic. I can do some tuning, like pinning CPUs. I can get that up to 4 gigs, 4.5, maybe 5 gigs. Or I can use something called PCI pass-through, where I give that virtual instance physical access to the interface. And now I'm home at 10 gigs again. But what did I just do? I just retied my virtual resources back to physical. So it's very much a balancing act. Do I want that elasticity and that flexibility? Do I want the ability to spin things up without any tweaks and I've got nothing tied to hardware anymore? Or do I still want line rate 64-byte packets, in which case maybe it's still better just to go buy an appliance, with custom-made ASICs. So there's not one answer to that, but there are different angles that I think we need to take into consideration when we have the conversation. Is that fair?
Yes.
Okay, cool. Here we go.
DPDK.
DPDK.
Yeah. Data plane development kit.
Mm-hmm.
It's going to come onboarding or offboarding.
Is it going to come?
It's eventually going to come.
Oh, so it's, I would say, the question was DPDK. There's something Intel's rolled out, and they've open sourced, I believe, called the DPDK, where you can get it gives virtual instances much greater and better access to the hardware underneath. Gives a lot better performance. It's here today. In fact, we've got it on all our products as well. I would suggest looking at something called FIDO. We open sourced, we had a scheduler within Cisco that one of our old fellows wrote 10, 15 years ago. We just open sourced it like 4 or 5 months ago. So go check out FDIO, and we're seeing 2.5, 3 times the performance of DPDK with that actually.
Didn't it start out as BPP inside of Cisco, and then you open sourced it, and it became FDIO.org is the organization?
Yep. Virtual Packet Processor is what it started as, BPP.
Depending on who you listen to, and if you believe the hype, some of the throughput capabilities, get up into the hundreds of gigabit. So, but like he says, you may have to trade off some other flexibility for that. But there's a lot of different ways to skin these cats. The other thing is that this is a completely different way of thinking about doing things. If what you're worried about is getting bottlenecks, then maybe the better way to do that is to spool up a whole other service chain of virtual functions to handle some of the workload. Okay.
Yep.
Would you have bare metal other than x86?
Oh, just different processor cores? Anything's possible, but yeah, Intel x86 architecture is definitely the most popular that's out there. Oh, no.
Crypto forward.
Oh, yep. So Intel's putting more and more stuff in their chips every single generation. Any other questions? Oh, one in the back.
Yeah, so it looks like you can pack a lot of different vendors, a lot of different hardware, virtualized, say like on an ISR or something. You can get so many layers and so much complexity that a single person with their certifications might not be able to handle it. So when you have that, how do you write a service contract for your customer?
So that is a great question. How do you write a service contract for your customer when we're losing control over a lot of this stuff, right? We're going on somebody else's server, potentially somebody else's operating system. So it's a challenge. The model I've seen to date on how do we still do SLAs is that I've seen 2 approaches, both of which are ugly. You force them to stay on your appliances where you control the entire stack, or you, and this is ridiculous, I know, and I apologize for even saying it, I've just seen some major U.S. service providers go this approach, is I have 1 server, 1 hypervisor, 1 VNF. Okay, what is the advantage of cloud in that? But they can control it, right? So I think there's got to be some more flexibility. If you really want 5 nines, you have to, the only way you're going to be able to offer a 5 nines type service is when you control that entire stack. That's reality.
That's the same sort of question that the traditional telco people had when people started talking about doing voice over IP. If you stop and think about it, it's completely different how this works. We're going to have to stop and rethink how we do business, how we're organized, how we write contracts and all of that. And this is stuff that's new. We're learning as we go.
The other thing that's slightly different about this approach is you design your architecture with the expectation that 5 servers are going to catch on fire at any given day. Amazon expects 200 servers to catch on fire every day, and they design their architecture such that you don't see a blip. It fails over from one compute node to another network service kicks in. So you might hear in this space the analogy of pets versus cattle. So that analogy, so you've got the story, the reference real quick. A pet, bring it home as a puppy, you nurse it, you take it to the vet when it gets sick, it's a family member, versus cattle, I've got an image that I spin up. If it gets sick, I just kill it and I spin up another one, right? So that's the difference kind of between the VMware approach and the OpenStack approach is I'm going to get that ISO, I'm going to install the operating system, I'm going to patch it, I'm going to nurse this thing when it gets sick, virtual Windows server, whatever, and I needed redundant hardware, redundant Windows, redundant Exchange, redundancy all the way up, versus the cattle model is I'm just going to spray 50 out there, and if 5 catch on fire, I don't care because I got 45 others, and I'll monitor and spin up more.
But then there becomes a factor of how much idle stuff do you have laying around,
yes,
ready to be used.
Absolutely.
That's a cost factor.
So the question was, it's how much idle stuff do you have around versus using every resource that's out there. So that's the balance.
Yeah.
Think about the OpEx of not having to run to wherever it is the server was when it caught on fire, and quickly, let's get another one installed here, let's have it shipped here overnight. Some companies talk about, we empty the garbage once a week. In other words, when hardware things die, it's spooled up automatically using these new techniques, another one, and they go in once a week and they pull out the failed hardware and replace it. That's the new world.
There's one other thing I kind of glossed over because this is a technical presentation, but one of the real drivers of this entire space is time to market. If I can press it, it's like going to Amazon versus, let's say your marketing department wants to spin up a web server for 6 months. They need a database back end, they want a couple web servers. All right, so I order the servers, takes 6 to 8 weeks, I've got to rack, stack, power, cool. Somebody's got to do the OS, I've got to load up the application, and only then can my application team start developing something. Or I pull my corporate card, and 15 minutes later, I've got the entire thing spun up on Amazon. Time to market here, you save 90 days potentially. So time to market here, the ability to have this flexibility where I push a button, and seconds later that thing's spun up, that's kind of where we're going with this. That's one of the real drivers of this whole thing.
Well, using this analogy of, let's say, Amazon, well, they got their people that's on the technical side. You got yours, but, well, thing is that, okay, you got companies that, want to concentrate on a core business and just deal with that only, but they said, no, we want, the technical side done by an outside contractor or vendor. And this is done strictly that, where you've got that big split between the two. It's easy for the IT vendors to go and control everything and kind of run the company, as it were. But the problem is that, what if you get, say, with Amazon, they say, we want our people with IT backgrounds to go and, have their finger in the pie, as it were. Then what happens to the service levels of agreement, where they start saying, now we want these servers right here. We've had it all this time. Blah 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 blah. Kind of stuff. Now listen, I can whip out my corporate card, and everything will be up and running in about like that. And they say, no, we want to do it this way. Blah.
Did you talk about hybrid cloud?
Hybrid cloud.
That's what it sounds exactly like what he's
I can do it. So that's another way of doing it. Everything we talked about here, and the reason OpenStack was invented in the first place was to give you the option of doing the equivalent of Amazon in your own data center. So there are certain applications, there's certain intellectual property I'm just never going to trust to go out on an Azure or somebody else's infrastructure. So hybrid cloud is some applications I'm going to use in my own data center, and then when I need more, and they might always live there, but there are other ones that I might be willing to trust to live in Amazon's cloud. And the ability to move workloads in between those is another thing that's interesting. If I spin up a CSR 1KV, Cisco's virtual router, in Amazon, which we support, by the way, you can go out to Amazon and spin one up right now for a couple cents. How do I extend, and we have control engines that will do this, I can take my corporate security policy and seamlessly extend that into my cloud. So if I make a policy change in my corporate network, it gets extended into my virtual resources that are out there in Amazon.
Plus, depending on how you have the agreement with your cloud provider, you can have hooks into actually controlling your piece of the cloud on their system, or you can go all the way to, and I think we've talked about this before in here, with some possible viral nodes that we can spin up. You can actually do hardware as a service and spin up a physical machine and pay for that, such that you put on what you want, how you want to do it, but they're just providing the infrastructure. So there's all sorts of different levels of involvement, all the way from we just tell these guys we want the cloud and here's the applications, and they spin it up and they take care of it. Spool them lower up when the load gets high, spool them down when it goes low, to anything in between.
Cool. Any other questions? Oh, one over here, or two.
Question. Do you know any more specialized server farm that we can use? For example, the DSP server farm that we ever need for video coding, or just use it for a moment?
So we'll make sure I understand the question. Are like publicly available cloud resources?
Right. That's like other than x86, like for example, DSP farm. That you can use video coding or encoding or whatever.
Raspberry Pi, things like that.
Yeah.
Yeah.
So any that's available these days?
So just things I do as hobbies. The question was, what other platforms are out there? You can now put Canonical's Ubuntu on a Raspberry Pi, All right, so I'm wondering what you're going to be. I've got some ideas in the back of my head, because that gives me a lot of things. I've got Python, I've got Ansible, I've got a lot of things built into that operating system now that's, you know, $30, if that, right? And so it's interesting to see what can be done on that. You've got containers now. I can put Docker on a Raspberry Pi. So you can take this thing as far as you want. I read an article on the internet. Somebody wanted to learn Ceph storage. And so rather than go out and do a bunch of, they bought 3 Raspberry Pis and put USB, disks on them, and he built a Ceph cluster out of 3 Raspberry Pis. Was not cost-effective storage in the slightest, but it was a really cool experiment. You know?
A great learning environment.
It was a fantastic learning environment, absolutely. So yeah, there's a lot of stuff out there. I've got some ideas where I want to take an Arduino with a Raspberry Pi and then be able to control. I want a misting fan for my deck, but if I turn it on, I get drenched. So what if I could do 10 seconds on, 50 seconds off? You know, be able to control that dynamically from my phone. You know.
Yes, that would be.
Girls love that stuff. All right, question.
In answer to his question,
My wife loves that stuff. If there's any women in the audience,
there are special cloud providers that have the raster clouds set up, so you can buy raster time, just like you buy. But it's only a few cloud providers do that.
So I more tend to think like a specialized server, meaning like if you need a mass amount of DSP that process images.
Yeah.
So you got like the Intel NUC, maybe. And something else I might mention is DevStack. You can download something called DevStack and get OpenStack up and running in 30 minutes, 30 minutes. But yeah, the Intel NUC is a cheap server. That'd be another, potential option there. All right, one question in the back, yeah.
Wondering if you can give us a little bit detail on ACI and Nimbus. They're also used for cloud.
ACI and Nimbus? Okay, so the question was insight on ACI and Nimbus as it relates to this world?
Yes.
All right, so I'll speak to ACI. So there is an ACI plus OpenStack story. If you go Google group-based policies, or GBP, group-based policies, that would be the ACI plus OpenStack version. So OpenStack, you can actually abstract the intent of the network. So as an application developer, I know I need a router, I know I need this many networks, I know I need this many IPs. Push a magic button, and ACI will go take care of that whole thing for you. So that would be the ACI plus OpenStack. Nimbus, I'm not tracking, to be blatantly honest, so I'm going to skip that one if that's okay with you, because I'd just be making something up. I often do that. But in this case, you guys seem friendly enough. I won't make up answers on the fly. Okay. Any other questions? You guys want to see that demo, or?
Yeah.
While he's getting that set up, I've got a little training environment on OpenStack. I don't know whether or not we could squeeze that into one evening. We might have to spread that across multiple evenings. One night we do Keystone, another night we do Nova, and so forth. But if you guys are interested in doing something like that, you would have to stage a VirtualBox VM environment on your laptop to do the labs. But something we might think about if you're interested.
All right, so I'll show you OpenStack here real quick, if you've never seen it before. Are you guys reasonably familiar with VMware, vCenter, things like that? I'm guessing there's more experience with that in the room. So, again, this is more the cattle approach versus VMware being the pets. But we've got multiple hypervisors. This is in my lab, so I've got 3 physical servers. I've got what's called instances, or the VMs that are running. I'll just go through some of these. It might be easier. So in this case, in my lab, this is something I'm doing for NFV, for a service provider customer, and I'm hoping I remove the names to protect the innocent. But I've got some virtual CSRs running on this box. They're hitting various networks that I have up and running. Some of these are virtual networks that were spun up dynamically on the fly. They did not exist. There was no IP schemes. It just went and created this network on the fly because I need something between a virtual router and a virtual firewall. So I'm trying to decide how ambitious I'm feeling here. CentOS. So this is, Bobby saw me troubleshooting this earlier, so I'm going to show, hopefully, this will work.
So we can help, right?
Yeah, he'll fix it if it breaks. Source. Okay, cool. This is going to work. Hopefully this will work. So here's an example, by the way. So I've got Juniper style. This is tail left that you're looking at right here. Can you guys see this? Let me make it bigger. Okay, so I can do style of Juniper request. Spell request packages reload. Right. So that's a Juniper style CLI. On the fly, if I prefer the Cisco CLI, switch CLI, now I've got my enable prompt. So it's a different command, packages reload. So different syntax on the fly that do the exact same thing to this engine. So I can do show devices, device, or let's do something different. Show running config. I've got multiple devices in here, so this is going to look a little bit different.
Are you guys clear what we're looking at? We're looking at a Cisco,
this is tail left.
It's tail left.
Tail left. So I'm switching between Juniper and Cisco CLIs, just like I can do a show running config, but in this case, this system could be managing 1,000 devices or more. So instead of having one device, I've got to have the ability to discern which device I'm actually looking at. Show running config from all my devices, pick a specific device, and then whatever the name of that might be. But in this case, I don't think I have anything that I'm managing that you guys would recognize. Devices, yeah, there's nothing running there. So let me just see if I can do this real quick. All right, I'll check out OpenStack here, and I want to show you an example of things, of the elasticity of cloud, right? So I'm a customer, I want a service. Let's say it's a cloud VPN. Hopefully this works. And I'm going to do service. I want to do something called the VCE, the Virtual Customer Edge. We're going to call it Brin, hopefully. Put it on the PEV line. So this could be something you would do through a web portal. In this case, I'm just doing it through the CLI. But the APIs on this box, I could easily do this from a web portal. So I'm going to put it on VLAN 1777. I want my local BGP AS number to be 65, 100. I want my remote AS to be 65001. Okay, so now I can do a show, commit, dry run. So I can see the Yang model. This is what it's about to do, but in Yang, I can do the exact same thing, commit, dry run, output format XML, if that's more friendly. So again, these are models that I can do in whatever format I want. I can apply them to whatever endpoints that I want.
JSON?
Let's see if they do. Native CLI, I can do CLI. What are the CLI commands that are going to go? That's for ESC. But when I'm ready, I just hit commit, and hopefully this.
Now you're back.
Oh, I'm back.
You're away from your own for a second.
So running that command, I could have done through a web portal. I could have done it through the CLI. I've got multiple ways I can do that. Now a virtual CSR is spinning up with those details. I specified the AS numbers. I could put the host name. I could do whatever you want to do. I could dynamically put in firewall rules. And what I'm wanting, that service is now spinning up. It grabs, in some cases, the next IPs in the pool. I can specify IPs. The ability to dynamically spin up and down network functions is likely going to be how our jobs evolve over the next 10 years. Our CTO, our service provider CTO, Dave Ward, uses an example. He says in the old days, our jobs were design and operate and maintain networks. 10 years from now, or my job now, is to implement the systems such that the thermometer bird that drinks out of the water hits the key, the space key on the laptop, and new services start spinning up all by themselves. So this is an example of OpenStack, and if you want, by the way, we can go into it, show you guys something a little more familiar. I'll go into this one because it's already up and running. I've got the overview, I've got the log file, so I can go take a look at. And as we all in this room love, having a console, So I spun up a device called CSR4. This should look fairly familiar. It's on the network. Show IP interface brief. So believe it or not, even though I despised Linux back in the day, I despised coding, that plus a little network knowledge, I might have another year of employment, maybe even 2. So that's OpenStack. There are times, by the way, OpenStack, if you have redundancy, you have 3 control nodes typically. You typically have 3 nodes of Ceph storage or Swift or whatever you happen to be doing, and then I start adding compute nodes. So you're up to 7 nodes typically of overhead before I add my first compute node. A little bit of overhead there. So we're seeing a need show up in the industry where I don't want that much bloat. So remember that one box, that virtual ISR I showed you? This is the interface, the web interface. And I've also got control of this box, by the way, through tail left, so I can start spinning uploads here virtually as well. But I can see here, if I want to go deploy a VM, it gives me this nice little design palette. So let's say I want to do a new wireless LAN controller, all right? So I simply drop it down. I want to connect it to this network and this network. You can't see it. If I hit the deploy button, I don't have a wireless LAN controller image, but getting that thing up and running on the network is that easy. So they've done this really, really nicely. The only other thing to set up in the case of a router is how do I get to that console? So on the router port 20, the virtual router port 22, if I hit the IP of this whole box through 20,022, then I can get to the console. Instead of SSHing directly when I've got multiple devices. So at the end of the day, I can go manage my images. In this case, I think I've only got the one up and running on this particular box. But I've got a virtual CSR, I've got different flavors, how much throughput, remember the elasticity we talked about? How much memory do you want to give it, how many cores, so I can give it more or less of that hardware that's available. I can limit its resources, I can give it more. So this is kind of where we're going. Is it useful? Oh, question.
Yeah, how do you handle network security on this? For example, you have the ability to create network structures, cross vendors, very complex. Someone could launch a very complex distributed attack, send it out, and then evaporate the network from which it came before anyone could detect, collect, and respond. So do you keep an audit trail somewhere that can't be removed for law enforcement?
So can I summarize the question by saying, what about security in this new wacky world? And how do I verify that my services are up and running when I want them to be, and I protect them as much as possible? Is that fair?
Well, you protect the people that might not, that could be attacked by it, that aren't part of the network.
So to address the security in this space, I'll start with OpenStack. And there's things you can implement at every single layer, right? I can put in ACLs in the physical network before I even get to this space. I can do policy there. OpenStack in and of itself was designed to be a multi-tenant scenario. So they, by default, will not allow any traffic to a virtual port where the destination IP and the destination MAC don't match perfectly. So it's an anti-spoofing mechanism. There's only one problem with that for us. What is routing? Routing is where I'm spoofing the entire internet through a one router gateway. So by default, OpenStack networking completely breaks everything we would want to do in this room. So before I can even enable something like routing, I have to go and affect those default security policies to allow traffic more traffic in than a very specific match of destination MAC and destination IP. So that's at the OpenStack layer. And then this is iOS. We still have access control lists. We still have security. We have virtual ASA. There's some services I thought about demoing actually, and I can show you some slides. But we have a service called Virtual Managed Services, or VMS. And so we offer 3 different flavors of that right now. It's running, for example, in Telstra in Australia and Deutsche Telekom and various places here in the Americas.
Talk about virtualization of firewalls?
Not specifically. Everything we talked about routers also applies to firewalls.
Yeah.
And we can spin up the ASA. We've got a virtual ASA, the ASAV.
F10s, A5s, you know, almost every vendor out there that knows, you know, where the world is going is generating a virtual appliance, an NFV, to do the same thing that their main box does.
Yep.
So you can put that into the line. Did you talk about service chaining?
A little bit, I talked about network service.
Yeah, so you could basically service chain a firewall function, and OpenStack comes with a thing called Firewall as a service and Load Balancer as a service. They may not be the highest performing firewalls and load balancers you've ever seen, but you can certainly chain that into the path, just like you would manually, physically plumb a firewall into your network to address some of the security concerns you're talking about, as well as, did you mention security groups?
No, that's getting.
So that's another thing that you can do. It's kind of like ACLs inside of OpenStack. There's lots of tools.
Yep, a whole lot of tools. And it depends on which layer. Physical underlay, virtual underlay, virtual overlay. You've got all the OpenStack and virtualization pieces in there. The Linux bridges. You know, we've got to go through a Linux bridge before you can get to the physical bridge. So you've got a lot of different places. And OVS, OpenVSwitch, remember that virtual switch? There's a kernel space for better performance. Remember enable fast path, the old 7500 fast path.
Now you're showing your age.
Yeah, I know, I've been around for a while. But it's the same concept. The first packet in the olden days was processed, and then we'd program it, so we get much better flows, but you always took a hit with that first packet. The exact same concept exists in virtual Linux switching. I have to do user space processing of the first packet, and then I program it down into the kernel. And so, you know, both of those layers have security built in. There's a question.
Where does Python fit in this, what you demonstrated?
The entirety of OpenStack is built with Python. So if you know Python, there's some feature you don't like, some bug you find, you're more than welcome to go in and fix it yourself and upload it to the community, or have them review it. But the entirety of OpenStack is Python. I'm just too lazy to go write 200 lines of code. I'm too old and fat to go back and learn C. You know, I'm going to stay with Python as much as I can. It's not, you know,
There's a lot of the stuff that you can interface with OpenStack and NSO, or the ALF, if you will, is done via what's called a REST API call, and that's very simple to write some code in Python to simply issue the REST call, get the data back, and do whatever you want with it to initiate some of these functions. So
to query this API and get back all the information that's running on this box is 3 lines of code. I can do 3 lines of code. Yes?
I work for a company that uses OpenStack extensively for their cloud solution, and I was really surprised and thrilled to hear you talking about it tonight. I didn't even think it would come up, and I'm wondering what your take on OpenStack is as far as allowing a content delivery network to compete with Amazon, AWS. Like, is that what OpenStack's doing, allowing CDNs to, is that giving them a chance to compete? I've heard it's impossible to compete with them.
Let me repeat the question. I heard a couple questions in there.
Okay.
So first question was, can OpenStack help run a CDN? And then the other question was, can that then compete with the traditional Akamai's probably of the world?
I didn't realize there was 2 parts to that question, but yes.
Okay. So okay, I'm gonna handle it as 2 parts if that's okay.
Yeah,
with your permission.
Yes.
So OpenStack is a VIM. It's a virtual infrastructure manager, right? So I can spin up virtual Linux, virtual routers. I can spin up virtual firewall, whatever I want, as long as it's compliant with KVM Hypervisor. Theoretically, I should be able to spin up anything and everything that works on KVM, okay? Now, what application you run on that is totally up to you. So if you can come up with, to use an old account manager that I worked with years and years ago, whizzy bang bang app, okay? Whatever app you come up with, let's say it's a CDN app. Then it's up to you to have the business model to have that go compete. But OpenStack, it's free, so that's gonna help your business case, right? It's very, very scalable. There's some easy, low-hanging fruit to tune it. You can still do advanced things like PCI pass-through if you wanted. So I would answer that by saying it always comes down to the business case and competitive market things beyond just the technology, but it is an absolutely solid, scalable, you know, free, you know, virtual infrastructure manager. So that's why I split those things into 2. It's always about the business case at the end of the day, right?
Indeed, yeah, so it's safe to say that it just depends on how it's spun up, that how somebody's going to use that to compete with AWS.
Absolutely. Do you need to hire 50 open source ninjas to support it? You know, is there a way to outsource that? Is there a simpler model where I don't have to invest in 7 servers of overhead before I had my first compute node? Maybe there's a simpler model. All kinds of things to be taken into consideration. Is it scalable? Is it a scalable open source cloud? Absolutely. And I think it's gonna, it is emerging and may possibly has emerged as the open source, cloud.
Forgive me if you've already talked about this, but if you go to the OpenStack.org webpage, because you want to download OpenStack and get started with it, it first takes you to a marketing page where it lists Mirantis and Rackspace and IBM and HP and all of these other people that resell OpenStack with their own flavor and their own support. And then over here on the little small thing is like, oh, okay, here's DevStack if you want to go do it yourself. All right, which you can do, but the point I'm trying to make is a lot of these companies are reselling OpenStack, just like Ubuntu and Red Hat resell Linux packaged with their special things and their professional services and support if that's what you want to buy. Or you can go off and do it yourself.
Yep, you've got Hadoop out there, for example. Everybody's going crazy about Hadoop. It's open source. How do you get support? A company called Hortonworks. Their entire shtick is supporting Hadoop. So there's this new business model. Download the software for free. Use it as much as you want. If something goes wrong, oh, who do I call? It's open source, right? That's where these companies are modeling their services. Anyone else? Oh, one here.
Yeah, so what is Hadoop? I've heard of the name, but I don't know what it's
Okay. So Hadoop is completely not on the agenda today, but it is a piece of software that will allow you to do massive computations. Imagine like doing data mining across every phone call that was made in the United States in the year 2014. I'm just making stuff up off the top of my head.
Yeah, nobody in the government would want to do that.
Yeah, nobody whatsoever. But yeah, data mining, finding, there's marketing companies out there, the old grocery store thing, like you put the beer next to the diapers for a reason, right? The way you'd probably find out new things like that would be through massive data crunching. So Hadoop is a common tool of doing that.
Hadoop was the name of the creator's daughter's pet stuffed elephant, okay? So that's what he called the software, which is where probably Horton comes from.
Probably. Actually, I'll give you an example. Here's a real-world example. There's many translation from German to Spanish to English, right? Many translations. I can do word for word, and the syntax and the slang is probably not going to come out very well, right? So what Google does for their translator, and why it's arguably the best one out there, is they data mined every article that was translated by a professional from one language to another. And that way, when they see a sentence, they go hit this entire massive database, and they find that sentence or as close as they can get to it, and then give you that translation rather than this word for this word, and this word for this word, and this word for this.
So you take pictures of it with your phone and it's translating as you take the picture.
Yeah, OCRing it, optical character.
Yet again, another open source thing.
Yep, question over here.
Did you mention DevNet at all? The Cisco DevNet?
I
don't know if it's entirely open for.
That's a great suggestion. So if you're wanting to get into a lot, not all, but a lot of the Cisco angles on this stuff, for example, TALEF and various things like that, check out Cisco DevNet.
This is a Cisco community.
DevNet, that's Cisco.com?
Good question.
I have it bookmarked, I don't remember.
Yeah, it's a Cisco community that you can sign up for, where you can access a lot of this stuff and
take classes.
Yeah.
Do labs.
There's practice.
Spool up your own lab.
I know nothing, and I want to know where to start. This is not a bad spot.
Yeah, the TALEF stuff I actually downloaded yesterday that I just showed you earlier, where I launched that virtual router. I downloaded it from right here. So a lot of that stuff is out there and available.
And free.
Check it out. Yep, it's free. Absolutely. Cool. Any other questions?
What kind of images can you get that are going to cost you to put into this playing around?
That is an ever-changing, so the question was, what images can we get our hands on? So you can download CSR 1KV, our virtual router. I believe the same thing applies to the ASA, the Web Security Appliance, WSA. We're pushing virtual WAS quite a bit. virtual wireless LAN controller. What we typically do is download it, use it party on, but we're gonna throttle it to 100K throughput.
Did you buy your Viral Personal Edition? It's probably, I'm not joking.
It probably is.
Viral is OpenStack.
Yep.
With all of these various NFV appliances, even non-Cisco ones. And if they don't distribute it with Viral, you can probably download it and use OpenStack tools and put it in your Viral network simulator.
Which that's a great point, by the way. Third party, we have already, remember some of the other vendors that were on that previous slide, we've already certified them and various, like Fortinet. So the intent here is to give you the flexibility to run anything you really want to run. You know, we definitely want it to be Cisco if at all possible, but you know, we're not going to lock that down.
I don't know if this kind of covers anything, cost versus buying a physical appliance and having to do like physical router versus having a virtual router and putting it on your own hardware. What is the cost savings? What is the benefit from a cost analysis, return on investment?
Okay. So the cost, the question was costs of a virtual router versus a physical router, what your ROIs look like. So my knee-jerk reaction to that is, remember where I'm the systems architect, right? So that's my off-the-cuff answer. But the real answer to that is that there's different tiers. You know, are you buying one license? Are you buying 500 licenses? How much throughput? Do you need 10 gig throughput versus 1 gig? So there's many different ways to approach that.
There's some people that say, oh, I'm not interested in this because if you compare dedicated appliance costs, racked and stacked and wired, to, you know, having a whole bunch of racks of servers, the dedicated is actually upfront, CapEx-wise, cheaper still. But that ignores the fact of the OpEx, the opportunity cost, the agility to deploy new stuff. So sometimes you run into those sort of arguments.
Your SE will be able to make all those arguments for you.
Absolutely. Cool. Anyone else? Yes.
I'll be the last one. I want to thank Bren.
Oh, thank you.
You got more questions than any big speaker I've ever heard in the last
Oh, wow.
20 years.
Oh.
Because I was that unclear about everything. But I think there was more interest in what you presented than normal.
Awesome.
That's why I've been beating on your bushes to get you to come out and do this, because I knew it would be well received. So thank you.
Hopefully it was useful. I hope it was.
Oh, yeah.
I hope you don't mind me interjecting.
Come back again now, you hear?
So, again, one of the things that we've talked about as the officers is trying to work in more of this virtualization new world that everybody's going to in our presentations, in what we do, and how we're organized. So we'll be looking at doing more of these. Like I said, there's a possibility I might bring in a series of OpenStack lectures with, all right, we'll do 2 lectures, we'll do Neutron and Nova one night and Keystone and some of the elements of OpenStack with a little lab and you can play with on your computer, because you can load this entire environment in a virtual box and have a controller node and spool up instances and do all of this stuff from your laptop. So it's cool, cool stuff. All right, let's wrap everything up. We've got our tickets and drawings to do.
Anybody
So,
not got a ticket?
I have.
I got 21.
Still kind of going for ACI or not
Cisco is very much into APIC and ACI. If you've got a lot of stuff that does ACI and APIC,